Today, we will be discussing Chapter 2. The introduction to Chapter 2, really what it is, guys, is we're going to be talking about polynomials, okay? Polynomials are something that you should have studied in Algebra 2, so this chapter should be more of a review for you, okay? Can anybody tell me what a polynomial is? Polynomials. Anyone know what a polynomial is? No? It's all good. It is a function composed of multiple terms with different degrees. So that there's like a very non-math definition. I can give you a math definition, but you're not going to remember it. Okay? Does this kind of help you understand what's going on? Terms. Okay, terms with different degrees. So an example would be something like this. F of x equals, I don't know, ax to the n power plus bx to the n minus 1 power plus dot 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 plus, I don't know, px plus q plus, I don't know, z. Okay, so let's talk about what's going on here. First of all, I am saying that I have multiple terms with different powers. I'm calling the first power the nth power. Cool? And then the second one the nth minus 1 power. All that means is that the power went down by 1. What I'm saying is the polynomials would typically write them from highest degree to lowest degree, right? You can go all the way down to second power, first power, and then no power. Are you guys with me? What I am saying here is that A, B, C, D, P, Q, all these numbers, they have to be real numbers. Cool? Are we good? So do you remember what a polynomial is now? Yes? Today we will focus on a very specific type of polynomial, known as the quadratic. Yes? All right. So we're actually on 2.1, which is called a quadratic function. Okay. What makes a quadratic function quadratic? It has to have an exponent of what? 2. When you say that, I hope, what do you mean it has to have an exponent of 2? Like, can I have x cubed plus x squared? No. So it's not just about having an x squared. It's about the greatest has to be x squared. You guys with me? So an example of this we would say would be something like f of x equals ax squared plus bx plus c, such that a cannot equal to 0. Why would that need to be a requirement in order for this to be true? That a cannot equal to 0. Well, if it's 0, then I would have 0x squared, which would mean, are you a quadratic? No, then you wouldn't be a quadratic, right? So it's a requirement. A has to be greater than 0, cool? Or less than 0, yes. Cool, so A, B, and C are elements of the real numbers. Cool, it could be any number. It could be a fraction, it could be an integer, it could be a decimal, it could be positive, it could be negative, as long as it's a real number. Cool? All right. Graphically speaking, what do quadratics look like? A U shape known as a parabola. Cool? I'm going to draw an example of a parabola as such. Cool? Now, back in Algebra 2, you learned that the parabola has some parts to it. So let's talk about the parts of a parabola. In this case, the way that I drew it, the lowest point on this one has a name. It's called the vertex. Cool? And then there are 2 points that I'm going to be very interested in when you're dealing with quadratics. And they are known as roots or x-intercepts. Okay? So we've got this point right here. We have this point right here, which is an x-intercept. Here's another x-intercept. So I got a question for you. The degree of this polynomial is 2. Does that mean that if the degree is 2, do I have to have 2 x-intercepts? I want you to think of all the scenarios that you can think of with a quadratic. Does the degree of 2, which is a quadratic, does that mean that I have to have 2 x-intercepts? You're shaking your head. Why not? Anyone? Yes. Like, for example, the parent function. The parent function is still a degree of 2, right? But how many times does it touch the x-axis? Once. So, let's talk about this then. Can I touch it 2 times? Yes, I mean, I just gave you an example, right? Can I touch it 1 time? Yes, that's the parent function. Can I touch it 0 times? Absolutely. Matter of fact, then, does a quadratic, does it have to cross the x-axis? It doesn't have to. But what is the most amount of zeros you can have? 2. I can have at most 2 zeros, so at most 2, and then the least amount would have to be none. Are we okay with that? Okay? So, the other part about this is parabolas are symmetric. So we talked about symmetry in chapter 1. The parent function has what type of symmetry? Y equals x squared has got what type of symmetry? Asymmetrical? No, it is symmetrical. It's an even function because it's symmetric with respect to what? The y-axis, right? Now, is this function that I currently have here, is it even? No, it's not, because it doesn't have symmetry with respect to the y-axis. But is there some type of symmetry? Yes, there is. So, there is this imaginary line that you're going to have to know, which is known as the axis of symmetry. Are we good? So, to recap where we're going with this before we begin any problems, I am going to give you quadratic functions. Your job is going to be to come up with a graph. And in order to come up with a graph, you're going to need 3 things, 3 points. The vertex, the x-intercepts, if applicable, and then I might ask you about the axis of symmetry, which shouldn't be that bad to figure out. Cool? But to come up with a sketch, if I have the vertex and the x-intercepts, great. If I can't find x-intercepts, then I'll show you how we can go about it. Are we good? All right. Part of this section also deals with transformations, which I will not be teaching today because you learned them in chapter 1. We will not be going over transformations again. Cool? All right. Example number 1. Sketch the following quadratic. F of x is equal to 2x squared minus 5x minus 3. Okay? All right. I need to figure out 2 things. The x-intercepts, if applicable, and then I need to figure out the vertex. We're going to start out with what I think you should know how to find first, which is the x-intercepts. Okay? How do I find an x-intercept for any function? Set the function equal to 0. Beautiful. So I got to start out by saying, okay, so 2x squared minus 5x minus 3 is equal to 0. Beautiful. How do I solve something like this? Okay. The very first thing you should attempt is factoring. Does everything factor? Not everything factors. So if factoring fails, what should you try? The quadratic formula. Cool. There's other options, but I honestly don't like the quadratic formula. Okay, so let's hope that this factors. So I'm going to go ahead and attempt to factor this. So I know the only way that I can get a 2x squared is if one of the factors is 2x and then the other is x. And in order for me to get a 3, one of the factors has to be 3 and then the other one has to be 1. But the fact that there's a 2 here, the position of it will matter. Okay? The fact that this is negative also means that one of them is going to be plus and one of them is going to be minus. So I know I'm doing this mentally. If you have other strategies for factoring, then utilize those strategies yourself. Okay? So let's go ahead and think this through. If I take 2 times 3, I'm going to get a 6. Right? And then if I multiply x by a 1, I'm going to get a 1. I think I can combine that to make a 5 happen. So I have a feeling that I need to have the 3 here, and that I need to have the 1 here. Therefore, since I need it to be a -5, I need the bigger number to be negative, so I'm going to throw a negative there, which would create this as a positive. And I'm going to check my work. 2x times x creates a 2x squared. 2x times -3 gives me a -6x, plus x gives me a -5x, and then 1 times -3 gives me -3, which means I was able to successfully factor this out. Cool? Yes? Absolutely. Whatever method of factoring you guys have, utilize it. Cool? All right. What do you do after you factor? So that's a trick. I understand that like the trick works, but I want to understand why that trick works. It's not just switching the sign. I want you to think what this is saying. This is saying that I have some number, I don't know what the number is, and I'm multiplying that by another number, and it equals 0. How can that be possible? How can 2 numbers multiplied be equal to 0? If one of them is what? 0. So that's why you are going to take each one to figure out, well, what would make this 0? Or what would make this 0? Are you guys with me? Do you understand now why you do this? Like, you have to figure out what makes this 0. Okay, first one's easy. What makes the first one 0? X equals -1/2. Cool. And then x equals 3. Which means, thus far, I have 2 x-intercepts. Cool. I have x-intercepts, so I'm going to go ahead and label them. X-intercept at -1/2, comma 0, and 3, 0. Are we okay? Now, the only thing I need to figure out is the vertex. Okay? Where this is where I'm going to rely back on maybe what you remember from Algebra 2. If I give you a function in this form, which is ax squared plus bx plus c, does anyone know how you can figure out the vertex? There's a formula. Yes? Fantastic. You take the b value, you negate it, you divide it by 2a, and that gives you the x-coordinate. How do you get the y-coordinate? What do you... I'm sorry, what? Subbing it. Okay, fantastic. You're going to take the function, and you're going to input the value, which in this case is -b/2a. Cool? So let's do it. For this problem, what is your b value? -5. So if I do the negative of -5, what do I get? +5. Okay. Divided by 2a. What's the a value? So 2 times 2 is 4. All right, not a pretty number, but very doable. That means that the x-coordinate is 5/4. Cool? How do I obtain the y-coordinate? Plug it into the equation, which means this is 2 times 5/4 squared minus 5 times 5/4 minus 3. All I did was put in 5/4 into the equation. Cool? Which is operations that I feel that you can perform yourself. Okay? What's 5/4 squared? 25/16. Times 2? 50/16. We can simplify later. Cool? So again, 5 squared was 25/16. Times 2 is 50/16. Beautiful. What's -5 times 5/4? -25/4. And then last I have a -3. What do I need to do in order to make my life easier here? Common denominator. But you guys do realize that 50/16 I can reduce. They're both divisible by 4? By 2 at least, which would give me what denominator? So that would mean that I would have 25/8, which means the second fraction would become what? 50/8. Agreed? Which would mean the last fraction would become what over 8? 24/8. Beautiful. All right. We are 5/4, comma. All right, so we have 25 minus 50. Negative 25. Minus 24? Negative 49 over 8. Not pretty, but very doable. Okay? Questions so far? Now your job is to sketch this. Now, we did not get beautiful integers, so you're just going to do the best you can on a graph. Okay? All right. First of all, 5/4. Do you have an idea what 5/4 is? Okay, if you need to, you can turn this into 1.25 if necessary. Okay? 49 over 8. Okay. That's a little bit trickier. How much is that? And it's negative, right? For sure. So it's negative something. 6, because 6 times 8 is, so it'll be 6 and 1/8. Are you guys with me? So you can use that to help you when you're sketching this. All right, so I'm going to use that information now to come up with a sketch. Here we go. So here's an coordinate plane. Okay, so there you go, kind of, right? Plot the points, right? All of these points are relatively easy to plot, in my opinion. So negative 1/2, 0 would be located here, right? Negative 1/2, comma 0. And then the other 0 we had was 3, comma 0, right? Which would be right about there. Cool? My vertex would be located in quadrant 4, if you think about it. I am going 1 1/4, so 1.25 to the right, and then 6 and a little bit more and an 8, so about maybe right here. Yes? And we know the shape of a quadratic. You're going to draw a parabola. Go in that direction. You're going to go in that direction. Questions? So, you found the x-intercepts, you found the vertex, you found the sketch. The last thing I would ask you is, what is the axis of symmetry? The axis of symmetry would obviously be right here, right? X equals 5/4. Yes?
So they wouldn't ask for the y-intercept?
I can. What's the y-intercept?
3.
So if I go back all the way to the beginning, what's the y-intercept? Negative 3. How do we find it? Plug in 0 for x. Now, I don't need it, but I could find it if I wanted to, if you wanted to. Are you guys with me? Questions?
Would it ask for the y-intercept?
I personally will not ask you for the y-intercept. No. Yes? Just the what, I'm sorry? The C value? Yes, it will always be the C value. I agree. Cool? Questions? Are we good? Okay, we're going to do another example of something that unfortunately is not going to factor. Okay? All right, so any questions on this one before we move on? Okay, our next example, we are going to be doing the same thing. We are interested in figuring out the graph of this, so I need x-intercepts, vertex, etc., etc., etc. Okay? Now, what I am going to do for this example is I am going to show you a different method to solve these problems. So I'm going to do this differently. Okay? Last year, you were introduced to a certain formula that I'm going to write down, which looks like this. F of x is equal to a times x minus h squared plus k. Does this look familiar? Does anyone remember what this is called?
Vertex.
Vertex form. Okay, so this is called the vertex form. Of a quadratic. Yes?
Yes.
Okay. by looking at this, without doing any math, just by looking at this equation, you should be able to tell me that the vertex is located where? H, comma, K. One thing I want to bring your attention to is this says x minus h. So notice how I use the opposite value. And this says plus k, I use the same value. So the h, you will flip the sign, the k will remain the same. Are you guys with me? Okay. Now, here's the problem. This is very helpful if I give you a function that already looks like that, which is not what I did here, right? Let's make it look that way. Does anyone remember how you can turn something that looks like this into the vertex form?
A would be 2.
Yes. Well, A is 2, I agree. Oh, you mean A here? I agree with you. Yes, I would agree with you. But then the rest of it, how do I figure out the rest? Yes. Okay. So that's a little bit, I mean, not that you're wrong, and I agree with you. If you know some points on the graph, then we can start using points on the graph to try to connect this to this. I am totally with you. But there is a process where I don't count, because that's more like, not guess and check, but that's more like a whole procedure of getting a graph and then using the graph to kind of go backwards. Which you're right, we can do that. But there is a way that I can actually do this to here without using the graph at all. Ishan. Fantastic. We're going to use something called completion of the square. Guys, I need you to pay attention. This skill is necessary for the rest of this class, not just for this. You're going to need to know how to complete the square because it is going to come up several times this year. Okay? So here we go. To complete the square, Isaac was right. I actually need that A value, which right now is 2. I actually need it to be a 1, which is not a 1 right now. Okay? So the way to do this is I am going to begin this process by factoring out a 2, which would leave me with an x squared plus a 4x, right? Now this is key. You see the constant, which is 7? I'm not going to touch it. What I mean by that is I'm actually not going to put it as part of the parentheses. I am going to completely leave it outside of the parentheses. What I need you to understand is that right now I am not trying to use factoring techniques. I'm just using a process called completing the square. Are you guys with me? What you should recognize right now is that if I distribute the 2, I get a 2x squared, which is what I have. I get an 8x, what I have, and then the plus 7, which I have. So I haven't changed absolutely anything. Cool? What I want to do is I want to focus specifically on the region that's in the parentheses right now, which is the quadratic, whose A value is 1, which is what I needed it to be. Okay? In order for something to be a perfect square, there needs to be an ax squared, a bx, but there also has to be a c, which is what I currently don't have, which I need to find. Do you remember how to do it? Fantastic. To find it, you're going to take the b value, you're going to divide by 2, and you are going to square. Now, you're taking the b value of the one in the parentheses. Do not go back to the original. Okay? So in this case, what would we be looking at if I do b divided by 2 and I square it? So this would become a 4. Now we have to play a balancing game, guys. By me doing this, give me just a second, you do realize that if I multiply the 2 in, now I have a 2x squared, which I do have. I have an 8x, which I do have. But now I have a 2 times 4, which is 8, and then 8 plus 7 is 15, which is no longer the 7, which means I have completely changed this function. I need to fix it. It cannot be a 15. It needs to be a 7, so what do I need to do? Add and subtract what, I'm sorry? I'm sorry, I can't hear you. You do it to the other side? Unfortunately, I don't have another side. That's just there for me to say that I have a function. Yes, sir? Subtract 8 from the same side. Let's think about it. If I want you to think about it. Technically, 2 times 4 is 8. That means I technically added 8. If I'm adding 8, then I have to take away 8 in order to balance it out. Are you guys with me? And you can check it. If you multiply everything out and you combine terms, would you get back to 2x squared plus 8x plus 7? Now you will that you have the minus 8. All I have to do now is just take one extra step and just literally just combine these two things. And now this is a perfect square, which means it should factor. Okay? So here we go. Why did I do have a minus 8 here? Because if I do 2 times 4, that gives me an 8, which means I'm adding 8. Cool? All right. What does x squared plus 4x plus 4 factor into? X plus 2 times x plus 2, which is the same thing as saying x plus 2 squared. And then 7 minus 8, which now this looks like the vertex form. Agreed? Yes? Tell me what the vertex is. -2, -1. Beautiful. Okay? Now that I'm in this form, can I still find the x-intercepts? In this form. Well, it's not going to be as easy as the vertex, but can I still set this equal to 0? Absolutely. So I can say 2x plus 2 squared minus 1 is equal to 0. Tell me how to solve that. So actually I don't need to factor. What do I need to do? Come on. What do you mean by simplify? If I distribute, that's going to give me right back to this, which is going to be a lot of work. I don't have to go in that direction. Think about this. Can you help me get x plus 2 squared by itself? What do I do?
Add 1 to the other side and then divide by 2.
Beautiful. Add 1, divide by 2. You guys with me? Beautiful. Tell me, how do you get rid of the square?
Square root.
Square root both sides, right?
Yeah.
So this time I do have both sides, so I'm looking at x plus 2 is equal to the square root of 1/2. Yes? Okay. That is something that I would expect you to know how to take the square root. We'll talk about it in just a second. Okay. Then how do I get x by itself? Subtract 2. So can I say that x is equal to square root of 1/2 minus 2? Yes? Now, I do expect you to clean this up. The square root of 1/2 is the same thing of the square root of 1 over the square root of 2. Do you remember those properties of roots? Okay. One of those is a perfect square. What is it? So that means I get 1 over the square root of 2. Now, there is a technicality that we haven't done. When you're solving equations, that means you're looking for numbers. And when you take a square root, there is a possibility that the answer could either be positive or negative. So technically speaking, I should have put a plus or minus the moment I took the square root, which means this is plus or minus, which means this is plus or minus. Yes? All right. I'm going to get picky one last time before I can call that my answer. I don't like roots in the denominator. How do I get rid of it? Not square. Multiply the denominator and the numerator by square root of 2. Okay, so what happens when I multiply? Root 2 over 2 minus 2. Yes? Okay, let me ask you something. I mean, obviously this came out to be not pretty whatsoever. So let me ask you. If I went back to this problem right here, and I solved it as equal to 0, do you think this was factorable? Based on this answer? No. Which means, if something like this is not factorable, then you can use the quadratic formula, which is my assumption at this point that you know how to do. Okay? If you use the quadratic formula, you will obtain the exact same answer that we have here. Because if you remember the quadratic formula states something like this. There's a plus or minus involved, which we have ourselves. So technically, as you can see, the answer for us is -2 plus or minus the square root of 2 over 2. Yes? Which, I gotta be honest with you, we obtained it by completing the square, which in my opinion, in my personal opinion, is easier than the quadratic formula. But that's just your choice. Okay? Alright, we have a problem, because we gotta grab this. Yes, ma'am? Correct. I'm just showing you different methods of solving problems. You get to pick. Cool? So now, here's what we know. I have two x-intercepts up here, right? Because this is two values, because I have a plus or minus, and I have a vertex. Can you sketch this? Well, there's only one number that I'm worried about. What number would that be? Square root of 2 over 2. Well, let's start out with what we do know. We know the vertex. Okay, so let me go ahead and sketch a Cartesian plane. Okay, my vertex, according to this problem, which is what we found first, was negative 2, negative 1. Okay, negative 2, negative 1 is about right here. All right, I got a question for you. The roots that we got were negative 2 plus the square root of 2 over 2. Does anyone know what the square root of 2 over 2 is? To be honest with you, I don't expect you to, so let's go ahead and use common sense. You ready? Okay. I'm going to go to the side and ask you, okay, I don't know what the square root of 2 is. I don't know. But I know that the square root of 2 is less than the square root of 4. Do you guys agree? And I would also say that the square root of 2 is bigger than the square root of 1. Do you guys agree? Now, I chose perfect squares because you're going to be able to give me numbers. The square root of 1 would be 1, which is less than square root of 2, which is less than 2. Do you guys agree? Now, I'm not interested in the square root of 2. I'm interested in the square root of 2 divided by 2. So I'm going to divide this by 2, I'm going to divide this by 2, and I'm going to divide that by 2. Fair enough? So what that means is, bless you, is that the square root of 2 divided by 2 is more than 1/2, but it's less than what? 1. So I'm going to use this data to help me out. It's somewhere in between. You guys with me? So if you go back to the x-intercepts, remember my x-intercept, one of them says x is equal to negative 2 minus the square root of 2 over 2. Right? And then the other one is x is equal to negative 2 plus the square root of 2 over 2. Right? We're going to estimate here. I don't want an exact number, but I want you to think this through. If I have negative 2 and I take away more than 1/2, then where would I be at? So this is negative 2, right? This is negative 3. If I go and I subtract more than 1/2, would I go past the 3? Well, I can't because it's definitely not going to be more than 1. Are you guys with me? I should be, I don't want to label this, but I should be like, if this right here is 2.5, this value right here is negative 2.5, I should be a little bit further than that. Are you guys with me? So that means I am going to be about right there, a little bit less than the 2.5. Are you guys with me? Now, by the same logic, if I add a little bit more than 1/2, and I am currently at negative 2, if I add a little bit more than 1/2, where would I be at? Between negative 1 and negative 1.5, which I'm just going to go ahead and guess is about right here. You guys with me? Do you know what a parabola looks like? Fantastic. Going up. Going up. Axis of symmetry. X equals negative 2. Vertex, negative 2, comma, negative 1. X-intercepts, negative 2 minus the square root of 2 over 2, and negative 2 plus the square root of 2 over 2. Questions? All right. With these two topics, I hit everything you need to know about quadratics. This is like a week or 2 weeks worth of material in one class. I understand that. But this is a summary of what you did last year as far as quadratics. My assumption is, number one, that this helped you remember everything. But I am going to need you to, I know this is going to sound like this is quick, but I need you to know most of what we covered today literally by next class. This was something you were supposed to know, right? So, that's it for today.